Okay, so we now have our 2 o'clock session, and this is called Imagining the Future and the Role of Human-Centered Design in Smart Service Systems. The chair is Paul Maglio. You heard his name mentioned a couple of times this morning. He's both at IBM, and now he's a university professor at University of California, Merced. And he is also one of the prime movers of smart service systems, and is the current editor-in-chief of the flagship journal in the area, Service Science. So, Paul, the floor is yours.
Great. All right, thanks, Dick. Thanks, everyone, for coming, and welcome. I'm really pleased to be here. We've got a great panel today. These are them, and you see them up here. But before we go into this, I want to just take you through a few little points. First, as Dick mentioned, Service Science is the flagship journal in the area. I would claim it's the only journal in the area. I'm biased. I'm the editor-in-chief of the journal. It's published by INFORMS, the Institute for Operations Research in the Management Sciences, and publishes innovative and original papers on all topics related to service with an emphasis on work that crosses traditional disciplinary boundaries. That phrase scares a lot of people, okay? It doesn't scare me, and it doesn't scare our journal. So if you have non-traditional papers about service, which I think you should if you're in this area, please send them along. Non-traditional paper about service. Pat Harker mentioned this earlier today. It actually came out yesterday, and I didn't get to tell him that. Published yesterday, Pat Harker's little rant and ramble about higher education kind of as a service system. So I encourage you to look at it. It's too bad he left. So I did want to update you a little bit. There was a reading on the reading list, which was the summary of a workshop that we held in March in Washington, D.C., which was, in my view, kind of the first workshop in a series of NSF-funded workshops to focus on a research agenda for service systems, smarter service systems, service innovation, whatever phrase you kind of want to use. So about 40 some odd people were there representing academia, industry, government. I think maybe 12 people who are here were there, something like that. And in the end, we came out with this idea that what we're really interested in, what we're really focused on are human-centered service systems, which are configurations of people, information, organizations, and technologies that operate together for mutual benefit. I really like that definition, not because the NSF picked up on it. Well, yeah, because the NSF picked up on it, but Jim and I wrote it originally, so that's why I like it. The other idea here was that modeling for human-centered service systems is really the key thing, but it's a slippery thing because the boundaries, what is a system, what constitutes a system, that's kind of hard to pin down, right? And it's also hard because it's hard to model those pesky people. Ultimately, performance depends on interactions and interdependent behaviors, which means human-centered service systems have emergent properties. Again, this is another scary notion. But if we're gonna play this game, if we're gonna think about these reality-based problems, this is what we're up against. We talked about a number of things. Again, I'm not going to go through the report in detail. I'm just going to highlight a few things. We talked about complex service systems in the context of urban infrastructure systems. We talked about them in the context of population health. We talked about them in the context of manufacturing and adding services into your manufacturing system. We talked about information and communication technologies and smart services, and particularly platforms. We talked about the potential service system revolution in education. Again, that goes back to what Harker was talking about. When we thought about a research agenda, we kind of organized it around these, what are they, six kind of themes, in a sense, okay? So where are the fundamental questions related to complex service systems? They're in theory. And this is, in some sense, this is the most basic question, right? Are there new principles or laws or, I don't like the word law, are there principles to be discovered about the operation of human-centered service systems? Are there things we don't know that we need to know about how these things work? Of course, data is important, but we don't necessarily know what all data we need. We certainly don't know how to manage it. There are going to be issues of privacy, among many other things. In terms of modeling, right? If modeling is key, how are we going to model these very complex systems that include people and technologies and organizations and information locked in these mutually value-creating relationships? That sounds kind of hard. We're going to have to make some simplifying assumptions in order to do it. Which are the right assumptions? Are they going to get us as far as we need to go? I don't know. I'm just laying out some questions here. I hope you all will solve them while we're up here talking. Design. I think design is another very important thing, and that's actually what we're going to talk about today on this panel, right? The need for a multidisciplinary or interdisciplinary or transdisciplinary science of design that enables us to put together complex human-centered service systems that take all of the different pieces into account in the right way. Measurement. How are we going to measure, and particularly how are we going to measure value creation? Another one of those slippery terms that scares a lot of people away. What is value and how do we measure it? Finally, education. If we do create this new thing of understanding and designing and measuring and collecting data on human-centered service systems, where are we going to put all that? How are we going to educate people with that? I think there are educational implications as well. So that's the beginning. That's my story. That's the summary of the previous workshop, and I'm really excited to see that NSF and MIT and all y'all are here to actually begin to think more deeply and more critically about these and other related problems. So we're going to move on to the rest of the panel now, and we're really going to talk very more specifically about the future and the role of human-centered design in smart service systems. And these are our panelists. And so first I'm going to ask Jack Carroll to come up. And I guess to me, he kind of needed no introduction, but I guess he needs an introduction to you. Jack Carroll is Distinguished Professor of Information Sciences and Technology at Penn State. He does research in all areas of HCI, especially facilitating collaboration and community through the internet. He works on service co-production, including time banks, volunteering, peer-to-peer exchange, and alternate currencies. And in a way, I followed Jack from IBM to academia, only he did it about, I don't know, a while ago. Anyway, please welcome Jack Carroll.
Thanks, Paul. Let's start at the beginning. So at lunch, I was talking to Dave Woods, and he was outlining a paper that he could present here, a set of thoughts he could present here. But he said, but these are the ones I don't have time to present. I already have a talk. And I realized there really are a lot of talks each of us could give that bear on this kind of vast topic. What I want to talk about, and I've taken my title, which I think is a really great title. I stole it. It's the subtitle of Edgar Cahn's 2000 book, No More Throwaway People. And I'll make a connection to that in a minute. But there are a lot of talks I could have given. I want to take Paul's challenge to talk about a principle of service science, which is co-production. So there are a lot of humans involved in services. We've talked about some of them this morning, but I guess the critique side of my talk is that a lot of times the recipient is in a passive role. I think Heather alluded to that when she talked about the disengaged clients at the VA. And the point of co-production is that the recipient is in an active role. So a definition of co-production is that provider and recipient contribute reciprocally to the success of the service. And this is this is very common. In fact, I would say all the services that Paul alluded to in his framing of the session involve co-production of this sort. The example I have here on the slide is a pretty sort of a custom service, but it conveys the idea of reciprocity. So, what I want to suggest in my remarks is that service co-production is an important model for us to understand if we want to facilitate and coordinate human activity. Moreover, co-production's moral, it's efficient, and it's innovative. In fact, co-production's really, and I'll show you a couple of examples, a source of disruptive innovation to frame services. However, I don't want to be too imperialistic. I mean, I realize there's different ways to look at service, and one thing I was reflecting on, because in a way, coming here, I'm coming back to other roots I have. 35 years ago, I was a postdoc with Noam Chomsky a few blocks from here. But Noam Chomsky had a view of language. He saw it as a formal structure. Claude Shannon saw language as signal and noise. Harvey Sachs saw language as a joint achievement that people coordinated in social interactions. Those three views are completely incompatible and irreconcilable, and they're all right. So I'm not claiming co-production is the only way to theorize services, but it is the way to theorize services at the level of human activity if we want them to be successful. So the origins of co-production. The idea, I think, comes from Jane Jacobs' book, The Death and Life of Great American Cities, where she remarked on the essential participation of elderly couples in urban neighborhoods who spend a lot of time at home, look out the window, and know what should be happening in the street. Well, that doesn't seem like much of a contribution. Nevertheless, in terms of statistics, it makes safer neighborhoods. So this is one thing to note about co-production. It's easy to miss. Elinor Ostrom, who won the Nobel Prize in 2009, actually coined the term co-production. And her example was similar. She was analyzing the service innovation of putting Chicago police in patrol cars instead of having them walk the beat. Well, this was a pretty innovative service change because it increased the crime rate. Because it turns out that a key thing for safety in the street is not how fast a cop moves through an urban landscape, but how well a cop moves through an urban landscape. And basically taking out the co-production with the community makes the cops faster and poorer. Edgar Kahn, I already alluded to, developed this idea in his book, No Throwaway People, in which he invented time banks. Time banks are small information systems that mediate human activity, basically treating time as a currency. So the value of contribution is how long it takes to do it, as opposed to other kinds of ways of valuing things. Kahn was, and is, he's still alive, was especially concerned with marginalized people, juvenile offenders, single mothers, recipients of social services, and how to bring them more toward the center of the community again. And in the intervening 15 years, time banks have proven to be able to do that, as it's kind of a movement spread through the world. Finally, the British National Health Service has incorporated time banking systemically. Two applications of note are that time banking supports aging in place. Elderly people are, in fact, participation in time banking is particularly attractive to elderly people. And aging in place, as we saw in the examples, especially the Jane Jacobs example, which is exactly that, support community safety as well as other objectives. In fact, just on this note, the social service sector of the economy is more than 25%, more than 25% of GDP. So this isn't just being nice. This is being efficient. It's making society possible. Another interesting thing is that the use of time banking as a prescription in the British National Health Services scheme for mood disorder, which you might know is the third most frequent reason for hospital admissions in the United States. This is in Britain, of course, this technique. The idea is that somebody presents with depression and they're prescribed to join a time bank and serve people. So, and as I guess I remarked on this earlier, many services can only succeed as co-production. So essentially any service involving learning, emotion, health and well-being, social support cannot succeed if it isn't a co-production, which I think the VA is learning, and of course universities know this. You can't teach people by presenting information. You have to teach people by engaging people in learning. They have to cooperate. I think you learn that when you're an assistant professor. But as I said, it's also highly innovative. So again, consider the NHS prescribing time bank service as treatment for depression. The person receiving this service earns time dollars by being treated. The treatment's not only free, it generates value. Think about that, the third most frequent reason for hospital admissions. And another example that's sort of burgeoning today in American culture is peer-to-peer service microenterprises that capitalize wasted resources and opportunities. These would be things like Uber and Airbnb, which are $10 billion gross companies. So it's not like a small activity. But these are co-productions. The co-production here emphasizes the shrinkage of top-down central mediators. Airbnb changes the cab company into a personal relationship between the cab driver and the rider. Okay, so my final point is that this isn't just pie in the sky. We can do this. We have ways of doing it. People in the field of HCI have been working on this problem for 35 years, and they have a whole raft of ways of solving these problems. It's essentially a familiar problem. So one thing we can do is to identify the active role of the recipient. Don't keep saying service delivery. Think about who's getting it delivered and what that means and what that person has to do to make that succeed. They have to do more than receive a service. So in HCI, we would use scenarios and personas for that. And I would contrast this to what's used in service technology today, service blueprinting. There's nothing wrong with a flow chart. You need flow charts, but you need a lot more. That's my point. We should focus on breakdown and workaround from the recipient's point of view in service relationships. Think about services as appropriable by recipients. Instead of customer journey maps, we saw one today. Essentially, again, an idealized flow chart that does not give any active role to the recipient. And a third suggestion, we can probe and articulate and refine the recipient's experience of the service. So in HCI, we do role play and experience prototypes, which here would be service experience prototypes. Again, instead of enumerating touch points, a standard service design technique, there's nothing wrong with enumerating touch points. It's just not enough. That's my point. I guess that my final point would be, again, a lesson from HCI. we learned you can't add it later. So it really isn't good enough to design a logically well-specified service and then add in the co-production. Nobody's been able to add usability to a poorly designed piece of equipment. And my guess is that this will be true with services. We have to take co-production on board from the start. Thank you.
All right, do we have to change computers? Ready to go?
Should we shut this?
I want to do whatever he wants to do.
Okay. He's in charge.
He's in charge. That's what I'm here for. All right, so. Okay, sure. So while we're setting up, I'm going to introduce Kent Larson. Kent Larson directs the MIT Media Lab's Changing Places group. He's also affiliated with the MIT School of Architecture and Planning. His current research focuses on responsive urban housing, new urban vehicles, and ubiquitous technologies. And perhaps more importantly, he was a practicing architect for 15 years. So
Okay.
I'll give you Kent Larson.
Thank you. It's great to be here. And a couple of weeks ago, I was actually down in Washington for this. I gave a talk at this meeting, the NSF Cyber Physical Systems Principal Investigators meeting. And Grace gave a talk, and I took out my cell phone. I snapped this slide. I hope you didn't mind. I never got the original presentation. It was about the emerging priorities, and this caught my eye. One of the top priorities is smart, safe, connected, vibrant urban spaces, and I couldn't agree more with that. And in fact, I don't really see the difference in that group and this group's focus. To me, it's really one and the same. If you're making cyber physical systems, they're really kind of meaningless without the service component. We are focused in our group mainly on cities. This is really important because 90% of the population growth will take place in cities, but even more interesting to me is that it's where almost all of the innovation will take place. Patents aren't a good proxy necessarily for innovation, but 93% of patent and inventions will take place in cities, but the world's not flat in that respect. It's mostly on the coast of the US, Northern Europe, Korea, Japan, a few other cities that have the attributes that are necessary. We've had, I would guess, maybe 15 to 20 cities come to us and say, we are developing innovation districts. Boston's developing a whole network of neighborhood innovation districts. I think, though, there's a very poor understanding of what is innovation. So the big question that we're asking is what enables vibrant, entrepreneurial, high-performance cities? I think that's probably how I would put the priority. This is a nice diagram that informs, this kind of research informs a lot of our work. It's an actual study of a workplace and human behavior done by colleagues at the Media Lab. It's a network of human interactions, and you can see this guy here does not communicate with many people. These people here in yellow, particularly that guy, are super networkers, and this is looking at how broad is your network, how deep is your network, how many people do you communicate with, how diverse are the people you communicate with, and if you have strong and wide social ties, you tend to be productive and innovative, and I think exactly the same thing takes place at the scale of a district in a city or even a region, and we think these are the three key parameters we have to focus on: density, proximity, diversity. And density is residential and employment density, cafes, et cetera. Proximity is how many options do you have from your home? We're home-centric, from your home to possible workplaces, recreation, shopping, et cetera. And diversity, not only demographic diversity, but diversity of housing options, activity options. And you manage all that by adding all these new systems, and this is where the technology and the services come into play. So modeling the integration, the sensing, et cetera, to understand human behavior, and then thinking about how people move, how they get fed, how they're housed. These are the key attributes. And if you can do that, quality of life goes up, jobs go up, and resource consumption goes down. So that's pretty much our research agenda. So let me tell you about some of the components we're working on. Starting at the lowest level, responsive technology, people-centric sensing. We built 10 years ago what I think is still the most highly instrumented living laboratory, domestic living laboratory ever built. It was in an apartment building. It was fairly normal aesthetics, nice cabinetry, but we had hundreds and hundreds of sensors, and we knew where people were, what they were doing, the systems they interacted with, the state of the environment, et cetera. And we used a set of little sensors, MIT environmental sensors, that were incidentally funded from a grant, by a grant from the NSF, that we called MITES, MIT Environmental Sensors, so we could sprinkle them around the environment, we could put them on body, we would just trick people out with all kinds of sensing, and we'd put them through domestic and exercise activities, and we would develop the activity recognition to understand their activities in real time. And just last month, for that work, we won the UBAComp Pervasive Computing 10-Year Impact Award related to activity recognition. So this is central to all our work. We're still using these little sensors even 10 years later because nothing exists commercially that duplicates it. This is a study funded by Siemens where we took tunable LED lights, activity recognition, we changed the color temperature and the intensity of the light. Actually, we have a little paper recognition system in the lamp. It recognizes paper, it turns it on, and we're testing not only energy savings. Blue light uses 30% less energy than full spectrum white light, but the acceptance of people to have this dynamically changing environment. And typically young people love it and baby boomers don't. But it's a really interesting thing to work on. We just have a new project we started literally 2 weeks ago, but we already have a prototype. It's sensing a sensible floor. It's a floor where we can get fairly fine-grained activity recognition. We can do all this with cameras and computer vision, but people don't like cameras in the space. So we're recognizing activities. There's this whole internet of things that is very popular. You have all these connected lights and displays and HVAC systems and appliances, et cetera. And so we're thinking that we should add to that, and we should do sensible surfaces, chairs and countertops and floors, et cetera. We have one student that's instrumenting now his grandmother's home and recognizing activities of daily living, which is actually probably the best early indicator of emerging cognitive and physical problems. So just by looking at sleeping behaviors and toiletry behaviors, socializing, food production, et cetera, behaviors in the home, that could trigger some early intervention. And then we're also at a building scale looking at how much information can we collect with sensing. This is the media lab where I work, and we have hundreds of sensors now that are collecting all kinds of information, including where people are and how they're communicating. Of course, all anonymized. We're collecting audio, but it's all garbled, so we're dealing carefully with the privacy issues. To me, that's just kind of the enabling infrastructure. Now we're thinking about what we call places on demand, transformable homes and co-working. And it's an extraordinarily important problem. This is Mayor Bloomberg, former Mayor Bloomberg, in a 300 square foot micro unit. He says that the lack of affordable housing is probably the biggest challenge for New York City. Menino in Boston said the same thing. Young people want to live and work in creative cities, but they're getting priced out of that market, so the cities are becoming less creative. So we thought we could do better. So we're trying to work on very tiny apartments that are so cool that people want to live there rather than a bigger apartment. This is a prototype that we did of a 200 square foot apartment that has a queen-size bed, converts to an office with an 8-foot desk, converts to a dining space for 6 or 8 people, By the way, nothing's faked. We're looking at all kinds of interfaces, gestures, voice recognition, touch sensors, tiny little bathroom, but you open it up to have a handicap-accessible walk-in bathroom. We have a very small, efficient, compact kitchen, but you can double the counter space, et cetera. Now, in the future, I think we'll get away from rental apartments and condominiums ownership. I think it will be some hybrid, and housing will be a service model, and your environment will be personalized in a very compelling way. We're developing now all of the standard platform to allow for transformation. I think for us, this is the next step beyond the Internet of Things. It's the Internet of Things that create the environments where people live and work. We've prototyped movable walls and things that drop down from the ceiling, beds and desks to create hyper-efficient environments. We're having a lot of fun with that. We just, a few months ago, did a little robotic furniture piece. Now, the reason we did this is because office space is becoming more of a service model. There's co-working facilities, but you have a whole range of companies in and out, different needs, different spatial needs, different equipment needs. So we thought, let's create a totally transformable environment with robotic furniture so we can create office space on demand. Food for Cities is one of our newest projects. Food production for us is really one example of very light manufacturing that will enter the city and create a wider assortment of jobs for people right in the city. Food security is a huge issue. These countries in green are the food secure countries. Northern Europe, North America, and Australia, basically. These are all the food insecure countries, which I think looking into the future means war and famine if we don't deal with that problem. I'm an urban gardener, but this is my garden, but this does not scale. It's not a solution. This is industrialized farming in places like Southern California, which uses way too much water and energy and remote from the consumption. So we thought, let's develop the technology to produce food at scale near where consumption. So this is our first food lab, where we're testing hydroponics and aeroponics, and we regularly produce enough food to feed the whole lab, and we donate the excess to the food shelters. This is our new lab that we just built a couple of months ago. We're integrated into the facade of the media lab, and these are our young farmers, the undergraduates. We have about 10 Europs, as we call them, working on the project. Here you can see the roots from the aeroponics. It's just misting the roots with nutrients and water. And we think food production can eventually become a service, a personalized service with things. They're not great actors. So in soil, we can grow about three heads of broccoli per square foot per year. Aeroponics that we're working with can do about 18 per square foot per year. But if you were to skin a building with lightweight food production, the height of the Prudential Tower, you can get 1,080 times the production per square foot of land. I don't know if these numbers will check out. That's why we're building this lab. But anyway, that's the goal. Looks like 90% less water, 60% less fertilizer. And we just, 2 weeks ago, partnered with the Culinary Institute of America to do a conference. The subtitle was Innovation at the Intersection of Technology, Behavior, Design, and Food. And I think we all agreed technology was important. Behavior change and figuring out the service models were probably the most challenging. Mobility on demand, creating alternatives to private automobiles. Private cars just kill innovation. I mean, we have to figure out how to get rid of them in central cities. So we're looking at service models for lightweight, shared use, electric vehicles of many modes. These are all the modes that we're advocating. By far the most important is walking, which is, shared streets and sidewalks. But you should also have shared bikes, you should have trams. Eventually this will be all on demand. It won't be fixed routes, it'll be routed with powerful algorithms on demand. The four here are the ones we've worked on in our lab and built. Little electric assist bicycles, three-wheelers, robo-scooter, the city car, and we like working with industry. We work closely with industry on many of these. This is the city car that we did a few years ago, started by my colleague Bill Mitchell, that has robot wheels. So drive motor, steering, braking, suspension, all in the wheel, plugs into the chassis like a USB port, frees the chassis up to fold, front door opens up, the length of the vehicle when folded is the width of a conventional car, so you can get 3-to-1. And we actually had one of our sponsors give us a nice grant to work with them. We build a full-scale prototype. We're doing this with other systems right now. We launched this at the EU headquarters with Barossa presiding. This is an example of EU-US social innovation. We had a happy sponsor that day. But that's a completed project. The new one that we're most excited about is a little lightweight, autonomous, three-wheel, single-person vehicle. Most of the trips in the city are 3 to 5 kilometers with one person. So we're working with our colleagues in AeroAstro to make a little autonomy mode, and this converts not in size, but from a people mover to a goods mover. So we think that if you design for peak load, meaning you need quite a few vehicles, then you have unused vehicles most of the time, so why not use them to deliver goods? Now, we haven't figured out the service model, but we think actually the goods mover could pay for the people mover if we do it right. With all of this, everything we're thinking about is shared use. And this is what's most powerful when you combine autonomy with vehicle sharing and electrification, and you have the sensor networks to know where people are in the load profiles, and you dynamically meet the demand. This is some modeling that we did of Kendall Square that's now based on real data showing the movement of private vehicles at peak load. If you can see down here, there are vehicles parking and user time, so you can dramatically reduce the number of vehicles and the parking requirement if you go to shared use. But the real benefit is when you go to autonomous vehicles that are shared. You can cut the number of vehicles by a factor of 3 and essentially eliminate all the parking. You eliminate turn lanes. You essentially eliminate accidents. But I think this only works in a compact, higher density district where you can really control the infrastructure and share infrastructure among the vehicles. So we're actually looking at ways of putting all this together. So in this little animation we did a few weeks ago, on the facade of a building, you have food production. It might be robotically harvested. The food goes into a new type of smaller shipping container that's automatically loaded onto small little distribution vehicles that take it around to markets and apartment buildings and grocery stores, and offloads it in some automated way. Whether it ends up like that, I'm not sure. But what we are sure of, there are a lot of companies that are interested in looking at that model. It's a much more rational way of distributing goods than the Amazon drone. And then finally, we're looking at urban co-creation. This is, I think, our most important project, where we're modeling cities using data units. We like working with Lego bricks. And we're looking at ways of integrating all of this data in the context of a district. We don't work at the scale of a city. We work at the scale of a district, about 1 square kilometer. Here we're modeling how we can put Kendall Square in harmony by adding enough housing, which is units for 53,000 people, so places of living, balanced places of work, to create a more walkable community. Of course, that would create a lot of traffic problems unless you had the mobility interventions. And we're looking at things like satellite view, solar radiation, wind flows, mobility modes. Those are all easy, but it gets much more interesting when we can look at where the money is flowing. For example, this is where all the venture money is flowing in Kendall Square by sector. This is real data. We have a real-time Twitter feed. Here the student sends a tweet to #Cityscope. The Media Lab lights up, and the tweet is down there, and we can look at where all the activity is. This is a great proxy for creative activity of young people. And you'll see Media Lab, where I work, is probably the brightest. Seasale, probably about the same. The Sloan School, not so bright for some reason. 3rd Street, where all the new restaurants are, very active. Main Street is dead because of all the blank MIT facades that come down and hit the street, so there's no activity. The darkest building is a U.S. government Volpe Center for Transportation, not a single tweet coming out of that building. So it's really interesting to look at all of this different ways of visualizing data in the context of an urban environment. This is a portable city scope that we took to Brisbane for the design of a new city. They said, we've designed this great walkable city. We modeled it using Lego bricks where jobs are in red and housing is in blue. We can move the parametric sliders to change the density and other variables and get a real-time walk score and project a heat map of the walkability. Here he's moving jobs closer to the housing. The walk score is going up in real time. So we use this to meet with the city council in a co-creation process, much like what was discussed earlier, where the big challenge is not really the technology per se, but it's the decision-making, reaching a consensus, education of the public to understand what kind of community people want, and therefore what are the systems that can be integrated into that community. We did the same for a new district in Riyadh. Now we're building these three-dimensional tools that we're going to be trying out with the city of Boston with the new Neighborhood Innovation District project, where we can map different data, construction cost, energy, occupancy to these towers and physical elements. We can map different geometries to them and rapidly iterate with lots of different designs. There's no limit to what we can do. We can project data or facades onto the three-dimensional elements using three-dimensional projection mapping. This is now what we're focused on is human behavior. So you see, these are two office buildings. There's no interaction. They're too far apart. They're too low density. You bring in an apartment building, still no mixing. You add density to it. People start to mix. Then you add cafes and shops and restaurants. And if you know the profiles of the people, you can predict that some percentage of them will be creative interactions, which the social scientists tell us leads to innovation and new ideas. So these are the things where we can now do movement of people, vehicles, flow of goods, energy, et cetera. We're now looking at the harder things, which are much more interesting. Where are the creative collisions? Where are the areas that we're predicting are more livable or more productive? Where will you have higher GDP? What areas might be, you have higher incidence of obesity, crime, where are the culture zones? We could have 100 computer scientists working on these algorithms, but for us it's really exciting. The main message I want to say is we've tended to design cities for machines, okay? Optimizing traffic flow, for example. There are cities designed for people which work much better. And so if we can develop these compact, diverse, vibrant, walkable communities with strong social ties, emphasize that, bring in the new urban systems to privilege those attributes, it will lead to innovation, and then you get your smart cities and your eco-cities and low-carbon cities by default. Okay, but start with people and start with services, we think, because we need to design for people, not machines, and then add technology when useful. Thank you.
Okay, so our final speaker in this panel on the future of human-centered design for smart service systems is Brian Scassellati, who is professor of computer science, cognitive science, and mechanical engineering at Yale University, and he directs the NSF Expedition on socially assistive robotics. His research focuses on building embodied computational models of human social behavior, especially the developmental progression of early social skills.
Thanks, Paul.
Thank you.
So first I want to say Thank you. This is a fantastic group that I haven't been a part of before, and it's been a very interesting day. I work with services at a different scale than most of you do, in that all of the services I look at are one-on-one engagements. I'm going to try to introduce a little bit of the work that I do as sort of a different way to think about services, and the future point that I'll try to bring out as we go through this is the idea of really being able to provide personalized service. So in the world of robotics, assistive robotics is often talked about in terms of physically assistive devices. So for 30 or so years, we've had these physically assistive systems like the Locomat that helps with stroke rehabilitation. That is, it provides the same kinds of services and helps support the activities of a physical therapist. That is, if you've lost physical functionality, the robot helps you by providing support and by moving your limbs through a predefined trajectory that allows you to engage in therapy before you might be able to support your own weight, for example. I don't do this kind of stuff. I work with a kind of system that still provides that one-on-one support and coaching, but without physical contact. And I do a lot of work with kids, so most of our robots are cuter and furrier. So we work with what we call socially assistive robots. And these are systems that provide the kind of support that a good mentor, a good instructor, a good coach would provide, but not what a physical therapist would provide. So our vision is to be able to create robots that supplement what educators, therapists, parents, and clinicians are able to do, and to help teach social, emotional, and cognitive skills to children, including children with social and cognitive deficits, in order to accomplish some amount of long-term behavior change. So we're really looking at this one-on-one interactive model of a service where that service is directly applicable to what you are trying to accomplish as an individual. Now, let me give you one story of why we started off in this direction. And this is the point where I have to ask the folks in the back to shut off the webcast for a moment, because I'm going to show you data that is IRB protected and HIPAA protected, that we have permission to show locally but not to broadcast. So this is work that we've been doing in conjunction with the Yale School of Medicine and the Yale Child Study Center. And we do a lot of work with kids with autism. And for a lot of these children, they're engaged in anywhere from 5 to 7 hours of behavioral therapy a day. And that is an extremely intensive and extremely labor-intensive and extremely demanding set of requirements for a service. So we started talking about 14 years ago or so about whether or not we could provide some type of technological support to being able to do that. And things went better than we could have expected. This is a 12-year-old boy, high-functioning, verbal, and he's focused in this task on trying to practice vocal intonation, what's called prosody. That is, he knows the right words to say, but he'll often say them in an inappropriate monotone or with the wrong inflection. And so to practice this, he engages in a couple of hours of therapy a day in which he gets put in a situation, a therapist will say to him, oh, look, I have an ice cream cone, but it fell. And he's supposed to say something that sounds consoling. And so we took a robot and we put it in this situation and said, let's let him practice with the robot. And what I want you to notice is I want you to notice the difference in his behavior before and after he engages with the robot. Now, in this little vignette, we changed it from ice cream cones. Robots don't like ice cream, they don't eat. But instead, we had the robot walk across this little play mat, and we told him the robot was afraid of water. And his job was to say something that sounded encouraging anytime the robot got close to the water. So here you go. Now, this is his typical behavior. He's not facing us. He's not looking at us. He's not really responding to our questions. He's echolalic. And then we bring out this little dinosaur robot for him to work with. And you can see he's very excited, he's very engaged. But you're also going to see him do something. He's going to glance over to the woman in the brown shirt, and he's going to do it 2 or 3 times in the next minute. There's one. And that's a behavior called social referencing. That's something we never see him do in other cases. There he does it again. And here he is after 5 minutes with the robot. He's engaged with the conversation, he's orienting towards us, he's making appropriate conversation, he's asking questions. It's almost like we have a completely different child after 5 minutes. And so we got very excited by that as an idea of what could we do to provide service in this situation. Now, the terrible part to this is that this didn't really work. Because we brought the robot back the second day and it worked fantastically, and we brought it back the third day and the fourth day and it worked great. And by the 5th day, he was bored with it, and he was tired of it, and he wasn't interested in engaging with the same story. So we started thinking about this, and we said, this is really a technology problem. What we don't have is we don't have systems that can really engage over the long period of time and adapt to this child. And so we went to NSF, and we pitched this as an idea, and they funded what was called an expedition in computing. Which is a large project that we're about halfway through. It's a 5-year program, 15 PIs scattered across 5 universities. And our vision is to try to be able to build these long-term adaptive systems that understand which skills the child needs work with, are personalized and customized to their goals, and can develop and change as the child does. But perhaps most importantly, this isn't a toy, and it isn't a teacher. It engages the child in the way that we know that they learn best, as a peer. Peer-to-peer interactions are where all the learning really happens. Now, in order to do this, we have to focus on how to get from that sort of 5-minute interaction that we're able to generate under the well-controlled conditions in the lab and get to the point where we can send these out into schools and homes for periods of months or years. And that means we have to do a lot more to build intelligence, to build smart services into that robot. We have to be able to model the dynamics of the interaction to know when the child is frustrated and disengaged, and to know individually how to get them motivated again, how to personalize and understand which things they've understood and which things they haven't, and how to be able to guide them towards some long-term goal. Sometimes that means moving straight toward it, and sometimes that means taking a more circuitous route. Now, I want to end by showing you one more example. This is from more recent work. And for this, we were dealing not with kids with autism, but we've been working more in public schools, especially K through 4. And this, we're working with kids who speak Spanish and Portuguese at home, and they're going to interact with this little yellow robot called Keep On. We've been doing this very minimalistic system in part so that we can try to make them inexpensive enough that we can replicate them and send them out en masse, but also to keep them simple enough that it doesn't rely on something really flashy and showy and complex, but rather gets to the heart of the interaction. So these are kids who are in a public school system who are struggling to learn English at the same time as they're trying to keep up with the rest of their class. And so we give them a set of time twice a week with this robot, and the robot speaks to them in Spanish and asks them to translate some of the stories that they tell together into English, and then helps them out to learn. Now, this particular section that you're going to see, and I got to shut the video feed off again, this particular section is involved with translating the Spanish verb hacer. Now, in English, you sometimes translate that as make and sometimes as do, and it depends upon the context. And there are about 8 different rules for how the context affects which translation you would use. You would make a sandwich, you would never do a sandwich, and you would do your homework, you would never make your homework in English. So the robot, in this case, learns which of those contexts the child has been able to successfully master in the past and changes the story. so that it asks them to focus on those pieces of context that they haven't yet acquired. So here's just a clip of him early on. So instead of make more space, do a space more, he says. Now, we've been doing this in public schools. We've been deploying this in a number of different locations in the US based on where our partners are. And we've seen that even with a few weeks of engagement with this, we can take standardized test scores for these kids on this particular translation task and move them from the 20 to 30 percentile range up to 60 percentile with the robot, or when we personalize with the robot, to about 80 percentile on these standardized tests. So we know that this kind of personalization can have a huge impact on what kinds of adaptation and what kinds of adoption individuals will take for our services. So my story for you for the future is, it's all about personalization. And I'll end by saying we've done this not just with Spanish. If any of you are interested, we do anti-bullying programs for second and third graders. We've been teaching nutrition to first graders in inner city schools on the West Coast. We've been doing problem solving with teenagers who get angry a little too easily, let's say, and all sorts of other areas. And we've been seeing these same kinds of results from personalization. And I'd be happy to show you those when we're not being recorded. Anyway, thanks very much.